Okay, I'd like to invite basically the first person who speaks from Sverre, Dimitrios, Peng. What are your opinions about question number 1? COVID-19 and risk of airborne transmittance. Any takers for that question?
It has to be speculative anyway.
Yes, of course.
Of course, we are not epidemiologists or medical doctors. I think the indoor airborne transmittance of COVID-19 is highly controversial. So speculating about how the humidity would affect that transmittance is speculating quite far above or far beyond the level of established knowledge. I think perhaps a hint could be taken from the apparently very low transmittance of the virus in commercial airliners, where we have very, very low relative humidity, and at least it has been claimed that actually no passenger-to-passenger transmittance has been recorded yet. Also, it's not obvious that countries with cold climate has any higher spread of the virus than the warmer countries, but perhaps on the contrary. So I think it's probably mostly other ways of dissemination and transmittance of this virus than the airborne route anyway.
Okay, we could say that the jury is out on that.
I think the jury is far out.
And of course, airline cabins, you also have top-down ventilation, different kind of air distribution compared to the buildings, maybe.
Sure.
Okay, what about question 2? Any takers for that? It's related to new humidity control ventilation devices, things like humidity controlled extract fans and stuff. Isn't that a risk when it comes to, I mean, would that not be a problem with kind of like overventilation in the summer because it's very humid outside? Well, it's a high absolute humidity outside and then too low ventilation in winter? Any takers for that? It's a rather difficult question to answer, maybe.
No, it depends on
what do you feel of that, or Sverre?
Yeah, I can go first.
Sure.
I think it depends on what is the intended function of this product. I think there are products that are regulated with the difference in dew point between the outside and indoor air. So that could be useful for controlling humidity in cellars, crawl spaces, attics, and that sort of spaces. Only using relative humidity sensor as a control is sort of not that useful for the reasons you just stated. It could perhaps have some function in bathrooms, where they wouldn't react to the outdoor air, but they would react to a shower and start this extract. But it's certainly not a replacement for the ventilation that's there to support good indoor air quality.
Well, I mean, they do not react to CO2 or VOC concentrations. Yeah.
So it would, so it would be just to remove the unwanted extra high moisture, and not any other function. It's not a replacement for true ventilation, in my view.
Okay. I would like Kari to roll. Now, can you scroll up to the top of the screen? And we have some questions. We have to keep a time schedule. I understand that we should be finished by around sometime after 4:30. Okay, 10 minutes. This is not long.
Yeah.
Sverre, maybe we don't have time to answer all 4 questions, but because any questions you don't have time to answer, we can put in the report. You can give a written answer. But maybe question number 1 is very interesting. It's the issue of because you mentioned both relative and specific humidity as kind of potential requirements, if in your talk. Would you care to comment on that? Which should we in the future have recommendations for both?
I think it's relevant to look at relative humidity for your comfort in the indoor environment. At the same time, it's probably interesting to compare the inside and the outside absolute moisture level. So if you can have indoor-outdoor sensors and have an eye on the moisture excess, that will tell you a lot about the risk of condensation.
So that's basically that's a third parameter mentioned here, because I think specific humidity is one thing, but actually difference in specific humidity is a third thing.
Yes, yes. Or you could translate that to difference in between dew point and outdoor temperature, whatever. So anything that would give you an idea about the condensation risk would be a good delimiter for the eagerness to increase the relative humidity, which is a sort of risky business, even if it's desirable in some conditions.
Now, related to this, question 3, okay.
Yes.
Wooden floors, they crack.
Yep.
Dry winter.
Yep.
Okay, so obviously we don't want to, we want to have some kind of threshold value. Yeah.
Perhaps. In my view, I put humans over floors anytime. So I think we should focus on what is good for the people and start from there. And perhaps the wooden floors, they should be adapted to the climate zone where they are being used. So for a Nordic climate, you should use a wooden floor that has been dried to a lower level than what you would use in Italy or Spain. So actually a little bit of differentiation would help. Of course, the large differences between summer and winter situation is a problem for wooden floors anyway. But at least it's good to have something that's not starting to have problems as soon as you have a fall. And
okay. Thank you, Sverre. I was thinking maybe the 2 other questions you haven't answered. I'll invite you to give submit a written answer in the report. Is that okay?
Okay.
Yeah, sure. Fantastic. Dimitri, are you there?
I'm here, Peter.
Fantastic. Okay, yes. Kari, can you just show how many questions he has? Because I think, okay, 5 questions. Right. We'll have to take a pick. That's first one. Okay, clay. Didn't mention it. You mentioned wood.
Yeah, I mentioned good because I was actually invited to talk about timber buildings. So,
point. Okay.
But I can say briefly that there are studies in the literature that report findings from clay as well.
Yeah, but it has the same basically properties. You know, it's
well, it depends exactly on what we mean by clay. But in any case, it seems that it has also a very good potential. Yeah.
We're not thinking about adobe houses, but you can have some kind of gypsum replacement, I suppose.
Yeah, something like that.
Okay. Moving on. We have a long question. Question number. Dimitri, which question do you feel to answer in the time available?
I think I can use 2-3 minutes and to try to go through all of them.
Yeah.
So the question number 2 is a very good question. It has to do also with other parameters like sustainable forests, etc., etc. I would say that I'm not an opponent of. I'm not opposing the combination of CLT with other materials. So probably composite buildings might be also a very good solution. However, when it comes to the CLT in particular, and the use as the structural elements. The question when it comes to the moisture buffering is whether we can have it exposed in order to take in additional into account also this benefit. And
of course, for people who can't remember what CLT stands for, it's cross-laminated timber.
Cross-laminated timber, yeah. Then the question number 3 is also a very good question. It is indeed, I think we lack reliable data when it comes to what is the moisture load, and that's why I've been using also the ISO, the 13788, that defines or presents the moisture load in relation to the moisture excess. However, I would say that the Annex 41, the IEA Annex 41, has a very good database of moisture loads for typical activities and rooms, as well as the VDI 2078, which is the German standard. I would say that at least those two, and probably the R360P, is let's say documents that can provide reliable data.
But it's an interesting question. I think what it's saying is that been lots of field studies, and then from these field studies, they just measure humidity and they can estimate the production rate for a daily profile. But that's nothing. That is, of course, what you're measuring is actually a very much delayed profile, which is affected by the buffering.
Exactly.
But any of these documents the only way they can actually generate true production profiles is just by guessing. Somehow. They're all very unreliable, I would say. Isn't that right?
That's right. That's right. Yeah. Unfortunately, that's right. So in all these, let's say, studies, what they report is a result of the relative humidity, which, of course, even though you know the moisture production, you may guess the moisture production, you don't know really what is the moisture buffering. It's only from the surfaces, it's also from the bookshelves, it's also from the carpets, etc. And this relates also to the other question, which is also a very nice question, how the CLT building can compare to other buildings in case of normal furniture, carpets, and bookshelves. If I understand correctly, I think here the point of the question is to compare the CLT compared to the moisture buffering in CLT compared to the moisture buffering provided by other, like, for example, furniture, carpets, etc. I must admit that I don't really know what is the moisture buffering of the furniture, carpets, and bookshelves. However, in my view, it is much more controlled to know that you have, let's say, strong moisture buffering surfaces that can contribute to the ventilation when it comes to the control of the relative humidity, instead of letting the moisture being controlled by, let's say, furniture or carpets. And if I go to the question number 4, it is this refers to the field study at Os. This was after 8 hours that it was the experiment was for 8 hours humidification.
A succinct answer, please.
And now I see the question number 6. Haven't even managed to write that because to read that because it popped out now.
I think we have to move to Peng very soon.
I don't get. Maybe 6 is not a question. It's a comment, maybe. Yeah.
It's a comment. Yeah.
Okay. Great. Peng, are you there?
Yes, I'm
Great.
here.
Well, you've generated a lot of interest and a number of questions.
Mm-hmm.
As I said, we don't have to answer all of them, but I'd like at least we can maybe just very kind of crisp, sharp answers. Maybe should we use hygroscopic rotors instead of condensing? You know, condensing is just normal aluminium.
Yep. It's actually depends on the outdoor and the indoor conditions. Like I said in the presentation, if the indoor moisture production is really high, then there's probably you don't any need to recover the moisture. Then if you use the hydroscopic, then it could be give extremely high indoor humidity in that case. And also, I think what's this question is want to see that we need really efficient heat wheel to get condensation first. And I think the requirement and all the standards are nowadays pursuing higher and higher temperature efficiency, like in Norway 80% or sometimes 85%. So if the temperature is really low, then in a lot of time there's condensation actually in heat wheel.
There's a question about odor transfer. I think 2 questions related to odor transfer in these wheels. Odor could be, I understand it, water-soluble odors. So what's the best solution for this?
If it's desiccant wheel, then there are some studies shows that it could be some risk for the odor transfer. It could be soluble to the water vapor and then adhere to the surface of the wheel and release to the supply air. So one of the solutions to use this plate heat exchanger or membrane energy exchanger, which has less carryover and leakage.
Okay, so but in a very, very cold climate, then you have problems with frost.
Yep.
So maybe it's not so relevant.
No.
And okay. Questions. Kari? Are you there, Kari?
I'm still here.
Kari?
Yeah.
Okay, so could you just scroll a little bit up so we can see just the last question? I think we have time for like 1 or 2 more before we close the session. Question number 8, Peng. Could you give a comment on that?
Yes, I think the answer is yes. So if we use membrane exchanger, so we'll increase the moisture on general. So in some case, it will be above 60% of the relative humidity. But this again, also we should consider the building characteristics. So we are now talking about very insulated and airtight building. So in this case, the condensation risk is low, even for the higher relative humidity. But this is true if we use membrane energy exchanger, then the indoor moisture production is high, then it maybe give even higher relative humidity when we have this moisture recovery. So we need to somehow consider the different regions and different moisture production schedule for different families. Okay.
Thank you. And I understand that number 9 maybe has already been answered by your, you showed these psychometric charts in your talk. So the outdoor temperatures does, of course, affect the moisture recovery efficiency.
Yep.
I think take a look at the Peng's presentation and you'll get an answer to question 9.